right, ladies and gentlemen, we're looking at 3.6. We're going to prove theorems about perpendicular lines. So these theorems you're going to want to add to your theorem and postulate sheet. They will be on the quiz Friday. Theorem 3.8. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. So if angle 1 and angle 2 are congruent, and they make up a linear pair, then G and H must be perpendicular. Theorem 3.9. If two lines are perpendicular, then they must form 4 right angles. A and B are perpendicular, so angle 1, 2, 3, and 4 are all right angles. Theorem 3.10. If two sides of two adjacent acute angles are perpendicular, then the angles are complementary. So if AB is perpendicular to BC, then angle 1 and angle 2 are complementary. Let's do our proof. All right. First thing we're always going to write down is the given. So we've got ED is perpendicular to EF by given. Okay. What is this little box right here saying? Right angle. So angle DEF is a right angle by what? No. Perpendicular lines form 4 right angles. The R inside the angles means right angles. From the new thing we learned today. We knew they were perpendicular, therefore we know that they're right angles. Okay? So right angle is how many degrees? Okay, so DEF equals 90. That's by definition of right angles. Okay. Lines form 4 right angles. It is theorem 3.10 on the front. Okay, so what two angles are we given in that right angle? 7 and 8. So I know the measure of angle 7 plus the measure of angle 8 equals what? And how do I know that? They're angles and they're being what to each other? So it's angle addition. Okay, what's the definition of 90? We know that those are what kind of angles? Right. So I know angle 7 and angle 8 are complementary by definition of complementary. How do we feel about that proof? We will have to do more practice. Okay. For example 2, all we're going to do is more talk about perpendicular lines. Okay? So we're going to plot the points. A is 0, 1. C is -1, -2. Let's, before we move on, find the slope of that line. -2 minus 1 over -1 minus 0. We get -3 over -1, which is 3. Let's plot the next 2 points. -3, 2 is B. D is 3, 0. Okay, they look like they're perpendicular, right? Let's find the slope of these. 0 minus 2 over 3 minus a -3. We get -2 over 6, which reduces to -1/3. Are they perpendicular? Yes. AC is perpendicular to BD. Okay. Let's try the next one. We've got -2, -1 for A. C is 4, 1. So that's 1 minus -1 over 4 minus -2. Just become positive. We get 2 over 6, which is 1/3. Then we've got -2, 3 is B. And D is 0, -2. Okay, let's see. We've got -2 minus 3 over 0 minus a -2. Two negatives become plus. -2 minus 3 is -5. 0 plus 2 is 2. Are these perpendicular to each other? Are they parallel? Are the slopes the same? No. So these are neither. Okay, let's make sure we don't have any surprises on our homework before I move on. Okay, so your homework is page 194, 2 through 28 even. Okay. Number 2 and 4, you just have to use the new theorems I gave you to determine what they are. Number 6, you just have to find what the angle is missing. 8 and 9, you're just proving how they were parallel. 12 is a little bit difficult, but I think you can do it. 14, you're just telling me what's wrong. 16, you're finding the missing angle if you know they add up to 90. 18 and 20, just trying to figure out if they're parallel and why. 22 is a little bit harder, but I think you can do it. 28, you're going to have to use the distance formula to find the distance between two parallel lines. So you pick a point on one line and a point on the other line, find the distance between them. 26, you're just going to have to find your unknown angles and say what postulate theorem you use. 28 is slightly harder, but I think you can do it. Okay, so no big surprises on here. If you get stuck, please feel free to ask. And you should be getting out what in front of you right now? You're writing. You're handing in your notebook.